Hi, folks. This is a short video on antibiotic resistance, and I'm using this TED Ed video because it has great graphics and great explanation. Antibiotic resistance occurs as a result of natural selection. More specifically, it is directional selection because the whole idea behind antibiotic resistance is that bacteria become that are the strongest will survive and reproduce to form superbugs. I'm going to go ahead and play the video.
What if I told you there were trillions of tiny bacteria all around you? It's true. Microorganisms called bacteria were some of the first life forms to appear on Earth. Though they consist of only a single cell, their total biomass is greater than that of all plants and animals combined. And they live virtually everywhere: on the ground, in the water, on your kitchen table, on your skin, even inside you. Don't reach for the panic button just yet. Although you have 10 times more bacterial cells inside you than your body has human cells, many of these bacteria are harmless or even beneficial, helping digestion and immunity. But there are a few bad apples that can cause harmful infections, from minor inconveniences to deadly epidemics. Fortunately, there are amazing medicines designed to fight bacterial infections. Synthesized from chemicals or occurring naturally in things like mold, these antibiotics kill or neutralize bacteria by interrupting cell wall synthesis or interfering with vital processes like protein synthesis, all while
So, antibiotics are only used for bacterial infections. If you have a viral infection, an antibiotic is going to be completely useless. Number one, because viruses do not have cell walls, and viruses do not have a means for producing proteins. Viruses hijack cells in order to do that. So, a lot of times, antibiotics can be prescribed incorrectly if the infection is a viral infection instead of a bacterial infection. So antibiotics are useless against viral infections, and that can also contribute to antibiotic resistance.
leaving human cells unharmed. The deployment of antibiotics over the course of the 20th century has rendered many previously dangerous diseases easily treatable. But today, more and more of our antibiotics are becoming less effective. Did something go wrong to make them stop working? The problem is not with the antibiotics, but the bacteria they were made to fight. And the reason lies in Darwin's theory of natural selection. Just like any other organisms, individual bacteria can undergo random mutations. Many of these mutations are harmful or useless, but every now and then one comes along that gives its organism an edge in survival. And for a bacterium, a mutation making it resistant to a certain antibiotic gives quite the edge. As the non-resistant bacteria are killed off, which happens especially quickly in antibiotic-rich environments like hospitals, there is more room and resources for the resistant ones to thrive, passing along only the mutated genes that helped them do so. Reproduction isn't the only way to do this. Some can release their DNA upon death to be picked up by other bacteria, while others use a method called conjugation, connecting through pili to share their genes. Over time, the resistant genes proliferate, creating entire strains of resistant superbacteria. So how much time do we have before these superbugs take over? Well, in some bacteria, it's already happened. For instance, some strands of Staphylococcus aureus, which causes everything from skin infections to pneumonia and sepsis, have developed into MRSA, becoming resistant to beta-lactam antibiotics like penicillin, methicillin, and oxacillin.
So,
Thanks to a gene that
so Darwin's theory of natural selection states that organisms that can thrive and survive and reproduce, they are going to pass on the variations that allow that organism to adapt and survive and become more adapted over time. Bacteria replicate at a much faster rate than other organisms because they reproduce asexually. Therefore, these bacteria that are harmful that have these variations, they're going to survive, they're going to reproduce, and they're going to become more resistant to the antibiotics because of natural selection, because of their evolutionary fitness. And again, this is a directional selection. That is the type of natural selection that these bacteria are going to go through.
Replaces the protein beta lactams normally target and bind to, MRSA can keep making its cell walls unimpeded. Other superbacteria, like Salmonella, even sometimes produce enzymes like beta lactamase that break down antibiotic attackers before they can do any damage. And E. coli, a diverse group of bacteria that contains strains that cause diarrhea and kidney failure, can prevent the function of antibiotics like quinolones by actively booting any invaders that manage to enter the cell. But there is good news. Scientists are working to stay one step ahead of the bacteria. And although development of new antibiotics has slowed in recent years, the World Health Organization has made it a priority to develop novel treatments. Other scientists are investigating alternate solutions, such as phage therapy or using vaccines to prevent infections. Most importantly, curbing the excessive and unnecessary use of antibiotics, such as for minor infections that can resolve on their own, as well as
Okay, so they mentioned the misuse of antibiotics. Another example of misusing antibiotics in the clip, it says that a lot of the bacterial infections your body can fight on its own, and you don't necessarily need an antibiotic. But another way that we can create antibiotic resistance is that we don't take our antibiotics correctly. Most people, or some people, will be prescribed an antibiotic for a series of days. Let's, for example, say the doctor prescribes 10 days worth of antibiotics. If you are that person who has been prescribed 10 days of antibiotics and you take your antibiotics for 7 days, you have and you feel fine and you stop taking it, you have killed off the majority of the population of bacteria as a result of the antibiotic. But what is left over is the population of bacteria that has survived and reproduced, and you make it your bacterial infection susceptible to uh, natural selection. Those bacteria that are left over, they can have a mutation. They can become superbugs because you have quit taking your antibiotic. So the misuse of antibiotics and prescribing them is one way that we are causing this evolutionary arms race, as they state, and it is a contributing factor to antibiotic resistance.